Volcanoes are incredible natural wonders that can be both beautiful and deadly. They have shaped our planet's landscape and played a significant role in the evolution of life on Earth. Did you know a single eruption can change the world's climate? That's right. Volcanoes may seem like scary monsters that occasionally get upset and blow their tops, but they're actually complex geological wonders with a life cycle of their own. Let's find out how do volcanoes form. Volcanoes form when tectonic plates collide and one plate is pushed under the other. This causes the rocks in the mantle to melt and form magma. The magma then collects in a magma chamber and pressure builds up until it is released in an eruption. The type of eruption and the shape of the volcano depend on the type of magma and the amount of gas it contains. Magma that is rich in silica tends to be more viscous or thick, while magma that is less silica-rich is more fluid. The amount of gas dissolved in the magma also affects its viscosity. The more gas, the less viscous the magma. There are three main types of volcanoes: shield volcanoes, stratovolcanoes, and cinder cone volcanoes. Shield volcanoes are large, gently sloping volcanoes that are formed by fluid lava flows. Stratovolcanoes are tall, conical volcanoes with steep slopes that are formed by alternating layers of lava and ash. Cinder cone volcanoes are small, steep-sided cones that are formed by the accumulation of loose volcanic fragments. Now let's talk about eruptions. Some volcanoes erupt regularly, while others erupt only after long periods of inactivity. Eruptions can range from gentle lava flows to violent explosions that send ash and debris miles into the air. Most volcanoes follow a cycle of growth and eruption that repeats over time. As a volcano erupts, it builds up a cone-shaped pile of material. Over time, this pile grows larger and larger until the pressure inside the magma chamber becomes too great and the volcano erupts again. This cycle can repeat itself over and over for thousands or even millions of years. Some volcanoes, however, don't follow this regular pattern. These volcanoes are known as supervolcanoes, and they can produce eruptions of truly epic proportions. So, what exactly is a super-eruption? A super-eruption is an extremely powerful volcanic eruption that releases an enormous amount of material, energy, and heat into the atmosphere. The term super-eruption was coined in the 1980s and is used to describe eruptions that have a volcanic explosivity index or VE of 8 or higher. The VE is a scale that is used to measure the magnitude of volcanic eruptions based on the volume of material ejected and the eruption height. Eruptions with a VE of 4 or lower are considered small, while those with a VE of 5 or higher are considered large. Super-eruptions are extremely rare events that occur only a few times per million years. How do super-eruptions happen? The formation of a super-eruption begins with the buildup of magma in a magma chamber that is much larger than usual. This magma is typically highly viscous and contains a high percentage of silica. As the magma accumulates, pressure builds up until it overcomes the strength of the surrounding rock, and the super-eruption occurs. The eruption is characterized by a massive explosion that ejects vast amounts of ash, pumice, and other volcanic materials into the atmosphere. The eruption column can reach tens of kilometers into the atmosphere, and the ejected material can spread over hundreds of thousands of square kilometers. Let's look at some past super-eruptions. One of the most famous super-eruptions in history is the eruption of Mount Vesuvius in 79 AD. This eruption buried the Roman city of Pompeii in ash and killed thousands of people. However, in terms of total volume of material erupted, it was not a super-eruption. A true super-eruption occurred about 630,000 years ago at Yellowstone National Park in the United States. This eruption, known as the Huckleberry Ridge eruption, is estimated to have had a VE of 8 and released more than 2,500 cubic kilometers of ash and pumice. The eruption left behind a caldera that is now fueled by Yellowstone Lake. Another super-eruption that had global implications occurred about 74,000 years ago in Indonesia. The Toba eruption, named after the nearby Lake Toba, was one of the largest volcanic eruptions of the past 2 million years. It is believed to have had a V8 and released more than 2,800 cubic kilometers of ash and pumice. The eruption had a devastating impact on global temperatures, leading to a period of intense cold. This period, known as the Younger Dryas, lasted for about 1,300 years and had a profound impact on human evolution. Some scientists believe that the Toba eruption was a contributing factor to the genetic bottleneck that occurred in Homo sapiens, reducing the population to an estimated 400 to 10,000 individuals. This bottleneck is thought to have had a profound impact on human history, shaping our species' ability to adapt and evolve. Yellowstone is one of the most active supervolcanoes in the world. In fact, it has experienced 3 super-eruptions in the past 2 million years. The most recent one occurred about 630,000 years ago and was the largest eruption in North America during this time frame. The super-eruption created a massive caldera that is now home to Yellowstone Lake. The magma chamber beneath Yellowstone is still active, and the volcano continues to be monitored closely by scientists. So, what does the science say about how close we are to a super-eruption? Scientists use various techniques to monitor volcanoes and predict their behavior. At Yellowstone, scientists use GPS to track any changes in the shape of the volcano. They also use seismographs to detect earthquakes and gas emissions to identify areas where magma may be accumulating. Despite these monitoring efforts, it's impossible to know exactly when a super-eruption will occur. Some scientists believe that Yellowstone is due for another super-eruption, but it's unclear when this may happen. Others argue that super-eruptions are unpredictable and that there is no way to know when one will occur. What would happen if a super-eruption were to occur today? The impact of a super-eruption would be catastrophic. Ash clouds would block sunlight, leading to a volcanic winter. The global temperature would drop, and crops would fail. There would be a massive loss of life, and the world economy would collapse. It is estimated that a super-eruption at Yellowstone could cause up to 90% of the U.S. corn crop to fail and cause worldwide crop failures and starvation. About 130,000 people would die in the first year, and 33 million within the first few years. The economic impact of a super-eruption would be devastating, with the cost of cleanup and recovery projected to exceed $200 billion. What is science doing today to help us prepare for a potential super-eruption? Scientists are working hard to understand super-eruptions and develop ways to predict them. They are studying past eruptions to learn more about the mechanisms that drive these massive explosions and researching the history of the Yellowstone supervolcano. They are also developing new technologies to monitor volcanoes more closely and provide early warning signs of an impending eruption. One promising technology is the use of satellites to monitor changes in the shape of volcanoes and detect changes in gas emissions. In conclusion, volcanoes are both destructive and life-giving forces of nature. They can cause widespread devastation and loss of life, but they also create fertile soil and provide geothermal energy. Their power and unpredictability make them both fascinating and terrifying. But despite the risks, humans have always been drawn to volcanoes. We have built cities near them, worshipped them, and sought to harness their power. Hopefully, with continued scientific research and monitoring, we can learn to live alongside these incredible natural wonders and mitigate the risks they pose to human civilization. The Earth is alive, and volcanoes are its heartbeat. They remind us that our planet is dynamic and ever-changing. And while we may never be able to fully predict or control their behavior, we can continue to learn from them and strive to coexist with them in harmony. Thanks for watching. See you next time.